Dinesh? Dinesh?
Yes.
Dinesh, are you putting attendance?
No.
No, okay.
What?
No, Lakshman called me and was checking, so even I did not have information.
Yeah, I think most of us are there, and Velu will be joining in some time.
Okay, okay.
Only Velo is not
Yeah.
there. Otherwise, all nine of you guys are there. Out of 10. Okay. All right, guys. Okay, let's start. So I've yesterday uploaded many documents for you guys. Also, did you guys get the recording? So if some of you missed out the post-lunch session, I uploaded the recordings. I expect
Where
that.
can you see the recordings?
Yeah, sir, can you upload? Can you please send us to the Gmail IDs, because here in IOPEX it is blocking.
Okay, do one thing.
No. See, I have actually uploaded it in the drive. Okay, I can share it with you. Just can you just put your IOPEX mail IDs?
Yeah, sure. IOPEX or personal Gmail ID?
IOPEX. I have uploaded in the IOPEX.
Okay.
I'll share a folder called SD-WAN with you people. All this one will be uploaded there.
Okay, thank you.
I'm talking about what Abid sir shared in the drive, in the Google Drive.
Oh, that one, huh? Okay.
Yeah, SD-WAN day 1.
Okay.
That is yesterday's recording, right?
Is it the recording?
They are the recording, basically recording sessions for yesterday. Day 1 SD-WAN basically. That folder contains the recordings basically, which I uploaded. Still, if you want, basically, like maybe then in the WhatsApp group, just send me your Gmail IDs also for in case something is not there.
Yeah, I think Google Drive is not accessible inside IOPEX. Are you people able to access it?
No, it is not accessible.
No, not
Yeah.
Google Drive is not allowed for us.
I didn't get you.
Email.
I have access. Which Google Drive you are telling?
No,
Suraj,
you can able to
we are
access
not
it
able to access
Google
that.
Drive, not
No,
IFS
Google
Google
Drive.
Drive.
Hold on. No, but if link is there, the thing is that if you are doing it from your IOPEX laptop,
Yes.
then you can download it in your this one if the link is provided. But you cannot open your own Google Drive. But IOPEX Google Drive you can open. I have uploaded in the IOPEX Google Drive.
Okay.
I can share.
Okay.
You can check it only through your IOPEX mail.
It is in your Google Drive, and you will be sharing the link.
Yeah, it is in my IOPEX Google Drive.
Okay, fine then.
Is
You
it
are
fine?
sharing
We
it?
don't have access to Google Drive by using IOPEX email.
You can drop us email, so that
Okay,
we can
I'll do that. But you'll be able to access now. Then no problem.
we have to try it. We never tried it before, because once you share, we'll try and let you know.
Oh yes. Okay.
So just let me know also in case. Otherwise, then we'll upload it on through your Gmail IDs also later if things are not good. Okay.
Yes.
So let's continue, guys, with our discussion. So yesterday we had seen, basically, I explained you basically what is SDN, basically software defined, and it's a framework basically. And then we went through basically what is SD-WAN, basically software defined WAN, basically what exactly we would like to do in SD-WAN. And then we discussed what are the various planes of Cisco Viptela SD-WAN. Altogether, in fact, there are 4 planes. Basically, traditionally, we have only 3 planes: the control plane, management plane, and data plane. But over here we also have now one more new plane that is called as authentication plane, or basically orchestration plane. It is just to ensure the securities. We want to ensure that the devices they're communicating are basically the real genuine devices, like that. Then we saw about the various components of Cisco Viptela SD-WAN, correct? We have basically 4 planes, and for 4 planes we have 4 different components. Like for management plane we have the vManage controllers. For authentication plane we have the vBond controller. That's the most important component. And then basically for control plane, now with the control plane is no longer localized basically on each and every WAN device. It is rather centralized now. So we have one common centralized control plane which will provide all the routing information to all the WAN routers, like that. And finally the main component, means the actual component needed for any business to move the traffic, that is a WAN routers basically. And they are called as what? As I said, originally they were known as vEdges. Later on Cisco added their own family of routers for to be supported in SD-WAN, and they were called as cEdges. And together now vEdges, cEdges, we have a common term which is called as WAN edges. Clear, guys? Any questions? Then I also explained that basically the data plane traffic, that means the actual business traffic, when it is moving around, it will be not going, since the WAN service, the most popular WAN service organization will be using is the internet, and internet being the public cloud in most insecure network in the world. Data security is very important, and that's the reason by default the data whatever the data plane traffic will move, it will be always secured by IPsec tunnels. Then we have the other type of traffic, that is the management traffic or the control plane traffic or the authentication. All this traffic also now, since it is also going to go through the internet cloud, then we can't have that traffic also going clear text, and that's the reason that traffic is also secured by DTLS tunnels basically. And since SD-WAN is a scalable solution basically, so basically we have basically the PKI in basically the framework basically, and in PKI basically every device will have a unique signed digital certificate by some CA, like that. For the CA services, as I told you, Viptela, before it was acquired by Cisco, they had already done a tie-up with Symantec Corporation for providing the CA services. Now organizations basically, their customers basically, they have option that they can continue with Symantec for the CA services. They can basically they can choose some plan from Symantec as suggested by Viptela, or they can go with Cisco's CA services, or basically organizations, the customers are basically they have freedom to select whatever they CA service they want, third party. They can set up their own CA service also, like that. All said and done, let me show yesterday's diagram. Let me pull up that diagram for quick reference. The topology. So this is the lab topology which will be using basically in EVNG simulator for learning Cisco Viptela SD-WAN, understanding the concepts of Cisco Viptela SD-WAN basically. So yes, so there you can see now there are the 3 controllers I have placed basically: vManage, vBond, vSmart basically. Yesterday I also spoke about what there is some licensing file is needed from Cisco to authorize the WAN devices basically. That file is called as what? Serial file basically. Now this serial file basically, while when a customer has to log in with his customer account, whenever some customer organization will go for Cisco Viptela SD-WAN solution, they will have to create their customer login. Once they have created their customer login, they will log on using that customer login, and they will basically they have to create this license serial file basically. During the creation of the license serial file, one of the parameter which is mandatory to be provided by the customer is what? The vBond IP address. Cisco's recommendation is basically this vBond IP address must be a public IP address.
Abid sir, you are telling about customer login, right? In middle.
Yeah, on the Cisco, like let's say IOPEX decides to go for Cisco Viptela SD-WAN solution. So after negotiation, after basically taking the subscription, whatever, buying this product basically, then IOPEX Cisco guys will tell like, okay, now you create your customer account, or rather they can create a customer account, and they can give you the assign you the customer privileges, what exactly you are entitled as a customer to download. Maybe some iOS upgradation might be required. See, everyone cannot download. Like I'm a CCI basically, so I have a CCI login, but CCI login does not entitle me to download some iOS from Cisco side. Maybe not like a normal Cisco user is there. Let's say like somebody who has done maybe CCNA, CCNP, he also has a CCO login like that. So if he goes and if he's he's accessing Cisco's documentation, maybe that CCO login, maybe he'll get maybe let's say 1,000 documents only. But if I log in with my CCO login and having CCI privileges, for me maybe I can get maybe 2,000 documentation, more documentation. So there are different kinds of basically login accounts basically. So when a customer creates his account, Cisco guys will approve that account, that okay, this is a customer for SD-WAN, so they are entitled to download maybe the images required for SD-WAN. They cannot download, like we cannot download like Cisco for data center, they have Nexus family, so that is called as NXOS, like that. So since your SD-WAN customers can download only SD-WAN images, they cannot download Nexus basically. Data center customers, they can download Nexus images, they can't download SD-WAN. So every customer according to their product subscription, they will have some privileges. Okay. So so whenever a customer goes for this Cisco Viptela SD-WAN, that time they will have to create initially you might create only a guest account. They will approve it basically. They will approve and they will maybe upgrade it to the customer level basically. And what according to your subscription only, you will be entitled to documentation. You'll be entitled to the relevant iOS images and all basically. So that is it. So as I said, I was talking about this now. To create this license serial file basically, one of the important parameter is what? IP address. They will ask, okay, in the creation of that file, one parameter will be what? IP address. So customer has to they have to do proper prior thinking and everything, and they have to suggest one IP address, because that cannot be changed. You cannot change that IP address.
That will be public IP or
recommendation is public IP, but not necessarily. Like in my example, suppose you see like this, the person who gave me, he gave me this serial file based on a private IP 192.168.0.202, like that. So it's a recommendation like that. If it is a public IP, then possibly like Cisco might host on in their own Cisco cloud also, maybe like that somewhere. But it's not necessary it has to be public. It's a recommendation. Private can also work like that. Okay, So first thing basically in that license file is basically this vbond IP address. So this is vbond IP address. I'm sorry, okay. Now what is second thing? Every organization, they will have what? Some organization name, right? Like that. So the second parameter, which is most important, again is basically known as what? Organization name. For company, the customer has to provide an organization name, like that. So this is also like that. This is also basically very important. So these two parameters customer has to provide. Of course, organization name is like suppose basically I'm basically let's say my organization is Cisco. Okay. And if my organization name is Cisco, then when I'm creating this serial file, I will not say my organization name is Juniper, right? Why I will give somebody else name. So organization name, the customer will provide their own company name, like that, whatever name they want to provide. IP address, as I said, IP address, basically they have to think and like that. So these two parameters, organization, whoever is the admin, the guy who is going to coordinate with Cisco, basically, that admin basically, he has to provide these two information: vbond IP address and organization name, and based on that, basically, all this thing is going to work. So now, as I said, that I have this serial files, like I paid for somebody and then he gave me for my, for my lab environment, one serial file basically with the limited capability for learning. This is from learning point of view basically. And that's the reason for in our lab environment, the vbond IP address basically will remain like this. We cannot change anything. We cannot change it. So the IP address is 192 guys, 168.0.202. This will be the vbond IP address. And the organization name basically is yes, basically use uppercase everything. So this organization name and IP address we have to stick. Like we have to assume that okay, this is our organization. This is the IP address suggested by our organization to WIP Cisco, and then Cisco allowed us to create that serial file. I'll show that creation later, how to do that. That I already document I already shared. We cannot exactly create because I don't have that privilege, but we'll just go through these steps. So these two information, guys, we all have to follow while learning this Cisco WIP Tele SD-WAN. Okay. So now next is now, as I said, basically, like take example, this basically just for just for a moment, basically forget about Cisco WIP Tele SD-WAN and all. Just assume that basically you have some router here. You have a router here. You have basically a router here. Basically, you have an internet connection. This is your internet connection, guys. Like that, you have a LAN here. Basically, maybe over here you have multiple LANs. Basically, like that, something is there. We have two locations. So across the internet, basically, what we do basically, if I want that, suppose this is a network A and this is basically network B, and this is basically segment C basically. If A, B, C wants to communicate securely across internet, what we'll do?
IPsec.
Okay, so basically maybe suppose this is all A, B, C are all private IP addresses. So maybe we can private IP address we know not allowed on the internet basically. So normally people will do what basically natting. They will do natting basically. Maybe I don't want to do natting. Then what is my option? I want A and B, C to communicate using private IP address. So normally what we do between over here to here, what we do?
We'll create tunnel.
Create basically like kind of GRE, right?
Because GRE.
Like that.
Yeah.
And when we do this, we call this as what? VPN, right? But to do this with GRE VPN, or let's say IPsec VPN, like that. Before that, what is the requirement? Before that, what is the requirement? The requirement is what basically?
IPsec peers must be reachable.
Yes. Suppose this is router 1 and this is router 2 basically. Router 1 and router 2 must be reachable to each other, correct? Reachability has to be there before we can think of any further feature we want to implement, correct?
Yes.
Yes.
This reachability, we call it as what?
Underlay.
Underlay.
Yeah.
Clear, guys? So what is the meaning of
Yeah.
underlay? Underlay basically means is basically what? The connectivity requirement. You need to have some kind of reachability prior to doing any further implementations. So you need to have reachability underlay. Now in case of like internet, in case of internet basically, if you see in normally in case of internet, this will be only a default routes, correct? Or router 1 and router 2 will put a default internet routes basically, and then since if they have public IP, they will be able to communicate with each other. So if underlay is not there, can we set up GRE?
No.
So basically GRE will work over this underlay, right? And that's the reason this GRE VPN, this VPN, they were also called as what? Overlay VPNs. The GRE VPNs were also called as what? Overlay VPNs. Like that. GRE VPN, IPsec VPN, they were all known as what? Overlay VPNs. Like layer 3 overlay VPNs, basically, they were categorized. Also, like in case of, let's say, MPLS is also there. So MPLS VPN also comes under the same category, overlay VPNs. So the feature which we implement basically over some other underlying requirement, that is called as what? Basically overlay. So what about now this SD-WAN now, guys? This SD-WAN, does it also require an underlay? Yes.
Yes.
Over here also we require reachability. As I said before, you think of any SD-WAN, our devices must have reachability. They must at least know, they must be reaching, know each other, like that. Then we can integrate them as a family. Then we can make them work as a fabric, like that. So our SD-WAN is also what? An overlay, basically, overlay feature. Clear, guys? Underlay and overlay. So underlay basically is nothing but what? Your WAN. What WAN service you are going to use, basically. Normally the underlay will be your WAN service, what you want to use. Now in Cisco Viptela SD-WAN framework, basically, Cisco Viptela, they call this WAN service basically. This WAN service, they term it as transport, WAN transport. So ultimately, this is the transport through which the customer data will be flowing across, right? Moving across. So that's the reason, in Viptela SD-WAN reference, we have to remember that when I say sometimes transport, basically you have to understand it is basically the WAN service I'm talking about. So this transport, what is the most popular transport now? Internet. Is MPLS also supported? Yes. almost all the WAN services, all the WAN transports are supported basically. Customization basically is not, like limited to a specific kind of WAN service or WAN transport. As long as the reachability is there between the components, that's it. How you do that is irrelevant. Like that. Okay. So clear guys, underlay and overlay. Underlay is basically the WAN service, underlay is basically the WAN transport. And SD-WAN will be the overlay over this. It is going to work over this. All the communication, whatever the communication will happen, it will happen over this underlay basically. Okay.
So, yeah, so mean via internet, we are using underlay via our other VPNs like MPLS, GRE.
Yes.
There will be overlays.
Yeah.
Okay. Yeah. Yeah, I understood.
Yeah, clear. Because if you don't have the underlay, we cannot do any, even simple GRE we can't do. If router 1 and router 2, they are not communicating, you don't have reachability between them, then we can't even think of doing GRE like that. Same thing like, in same thing basically, if you take example, some ISP is there, they have basically so many routers inside, they want to run BGP. End to end, they want to run BGP. What they have to do basically? Before they can run basically BGP, that is within the organization, within the ISP, it will be called as what? IBGP, internal BGP, right? So to configure internal BGP, what is your underlay? IGP has to be there. Some ISP will run OSPF or ISIS, and we use because of OSPF routing or ISIS routing, all the BGP routers will have reachability to each other. Once you have reachability to each other, then what we do basically? Then we configure IBGP, and then if you guys have some kind of if you can relate to, we can make two routers BGP neighbors even if they are not physically connected to each other, right? Why? Because we have basically there is already reachability between the two routers. As long as we have reachability between the two routers, we can make them IBGP peers. So IBGP is nothing but like what? Overlay only over there also. And IGP is your underlay. So reachability is very important. First thing. Okay, guys. Overlay, underlay, clear?
Yes. So in SD-WAN, I mean Cisco SD-WAN, the overlay will be mostly the internet transport.
No.
Right?
No. SD-WAN itself will be the overlay. Internet is the underlay.
Sorry. Okay.
Before we do SD-WAN, we need to have this internet connection. We need to have this reachability like that. Okay. Okay. Now that let us relate this. So let us think of this basically. Let's take example. You see basically this. Basically. I need to just I need to explain couple of terms. Then only I'll go to the devices. Yesterday I mentioned two more parameters. If you guys remember, one parameter what I mentioned was basically system ID, correct?
Yes.
System ID. I mentioned system ID. The one more parameter I mentioned is what? Site basically.
Site ID.
Okay, like that. This is site ID basically. So these two parameters is there. Now today I just now I said what? Underlay. Underlay is what? Basically the WAN service which you are going to use, which the customer is going to use. So WAN service has to be there before, right? Without WAN service, no reachability will be there. If no reachability, then we cannot do anything in SD-WAN. So this is called as what? Basically transport. Like that. Okay, like that. So transport will be there. And now what is the ultimate goal basically of SD-WAN basically? What exactly, if you see this diagram on the screen, what a customer would like to do? Suppose you see here, I have here basically this is this is basically some user. If you see there is this user, And let's say this is a data center. Assume that this is some server over here. So what will be a customer's requirement? Customer's requirement will be what this user would like to access the application on this server in the data center, correct?
Yeah.
So basically he's going to send some traffic. He's going to send a traffic, maybe it will come like this, like that. Will a customer, would a customer like this traffic to go as it is across this link? No, right?
Encrypted.
If it goes as it is, then basically it will beat the purpose of SD-WAN, correct? So what I said, how the traffic will flow? It will flow secured, basically. Through what? Through this IPsec tunnel, correct? Like that.
Yes.
So whenever we do IPsec tunnel and all, we call that as what basically? When some customer is doing GRE tunneling across internet, when some customer does IPsec tunneling across internet, we call that as what? VPN, right? Because
Yeah.
you are using a public cloud to send your traffic privately, as if it's your own private network, but it's a virtual private network. It's not your physical private network. It's not lease line, basically, that only your data is flowing on that particular circuit. So when we do that, GRE VPNs across internet, when we do GRE across internet, when we do IPsec across internet, we call them as what? VPNs, correct? So same way over here also, the data which ultimately the data which is going to go through this internet, this underlay, the transport, okay, the data which is going to go through this transport, like that. Or maybe if you see here, let's say this, this is the VH, let's say this Dubai VH. This Dubai VH is, this vManage want to send traffic to this Dubai VH. So there will be like, this data plane device is communicating with the management plane, or maybe the data plane device is communicating with this control plane. So that traffic is also ultimately going to go through what? That traffic also will go through what? This same transport, correct? Suppose this vSmart is going to send some route information to this Dubai Vantage. So if it is sending this information, and this information ultimately still is also going to go through the same internet transport, right? Underlay.
Yes.
Like that. So can we allow that traffic also to go insecure? No. It will also go as what?
DTLS.
DTLS, like that. Means ultimately means this traffic is also going as what? Tunneling, right? Is also getting tunneled, like that. That means on this route, internet router, if service provider engineer, if they're basically capturing this customer traffic, what they will see, the data traffic which is going, they will see as one only ESP packets. They will be seeing them as what? ESP. And over here also what they will see, basically everything will be basically like what? Encrypted only, right? All the traffic for the service provider will be what? Encrypted. So ultimately that means what? Is this customer, this customer's traffic, basically, the SD-WAN traffic, is it all going secured across this underlay? Yes. And that means basically you have set up what? We have set up what? A VPN kind of thing. And there's a reason this is called as what? Transport VPN. Okay. Transport VPN, basically. So in Cisco Viptela SD-WAN, we also have the concept of VPN. This is called as what? VPN. Why it is called as VPN? Because the customer data will go across the internet securely. It will not go clear text. It will go encapsulated and encrypted inside some tunnels, basically. And that's and whenever we do like that, whenever we send traffic encapsulated and encrypted across tunnel, we call that as but VPN. So here also we have this VPN, and since this is the underlay is called as transport, and so we call this VPN, we call it as what? Transport VPN basically. Okay, like that. This is one thing basically. Now this is basically, I'm just going to draw just one, actually 3 controllers are there, but let us, I'm just going to draw, let's say VM and vManage, sorry, VM and vSmart, okay. And you have basically, this V edges, basically, V edge, V edge 1, so all these devices are there, right? In like that, you have all these devices, let's say. Now, as I said, hello. VBot is also there. I'm just for right now. I don't want to. Okay, let me draw that also.
Okay. Okay.
Okay, it doesn't matter. So we have these controllers like that. Now, how do we, how do I basically, as I said, no, initially also we require, initially we require some reachability access like that. Just think like that. These are V edges basically. Just think these are V edges. Okay, V edges are what basically? V edges are what? They're routers ultimately.
Routers.
Correct? They're routers. So suppose you have a brand new router. So how do you access the brand new routers?
Through console.
Through console basically, right? So the routers we use console basically like that and configure this. But what about the servers basically? Do servers have console? No, right?
If it is in VM, then we'll get a console kind of thing then.
In a VM environment, it will be like you will get a console basically like that.
Or in a hardware device, then there will be some kind of management port.
Yes, there will be some kind of management port. Correct, exactly. So like some devices like firewalls and all basically they come with a separate management port basically. And that management port by default will have basically what, if you connect that port to some switch and all one, and then you connect your laptop workstation and try to access it, it will have already management port means what, it will already have some IP address like that. Like take example our at home we have Wi-Fi modems basically. On the Wi-Fi modem, what happens basically? First time you open and you connect it, by default it comes with some IP address. By default it comes with basically with a user account, correct? So that using that basically IP address and using that user account basically we log in to that modem and then we configure according to our requirement like that. So same way over here also. Now my requirement is what, I want to manage these devices like that. I want to manage these devices. And as I said, this Cisco Viptela SD-WAN, this solution is what? It is going to be a single window approach. You're not going to go individually and basically you're going to manage all these devices separately. So I'm sitting basically over here basically. So how do I basically access this, initially I want to set up this let us say first I want to take care of these controllers. So how will I access this managing these controllers basically? They must be basically connected to what? Okay.
Internet.
So we require this basically we need to specify here what? An IP address.
Yes.
This servers we have to log in. You can connect the keyboard, mouse, maybe if they are servers, basically you connect this thing also, basically a monitor, and then basically you assign some IP address, and then your model your laptop, from where you're going to manage this server. Ultimately it can be also connected to this internet only, like that. So I want to send what? Management traffic. I want to send management traffic to these guys. Same way here also, like that. This guys basically will have one connection, then you must have this reachability. So initially, basically, I want to set up this my fabric, right? Initially, I want to set up this fabric basically, like that. So I want to have reachability to all these components, all the controllers and all these advantages. I need to have reachability. And the most easy way is what? For on every device, I assign an IP address, and on every device I configure a default route. And once I do that, then what will happen on all this? They become reachable to the whole world basically, kind of. So I am now sending what? Traffic. I'm sending basically what? The traffic which I'm going to send basically. This will be what? Or basically I'll just show logically, I'm sending something to here, I'm sending something to here, I'm sending to these guys. So this is how this will be all basically. I'm trying to set up the configuration, and I'm trying to set up this devices, right? So this will be called as what type of traffic? This will be the management plane traffic, right?
Yes.
This will be the management plane traffic, like that. Now, what system this Viptela guys, they basically they have kept an option that they said that okay, if customer want, they can have a separate connection for sending this management traffic to the devices. And when the customer is going to send this management traffic separately, like that, then this will be called as what? Management VPN. So now we have basically, first one was what? Transport VPN. Okay, now we have the second type of VPN, which is there in Cisco Viptel as given. It is called as what? Management VPN. So let's say basically, now you guys tell me, like that, this advantages.
Can you explain management VPN once again?
See, now basically in the very beginning, I have to do the configuration on all these devices, right? I have to do this configuration on all these devices basically. So how will I access all these devices? You will require what? You will basically require what? Basically some kind of connectivity, right?
Yeah.
In the very beginning itself, like that. In the very beginning, I require some kind of connectivity. How I'll get that connectivity? For all these devices, I'll take up what? Some internet connection, right?
Okay. Yeah.
So that internet connection now is basically the underlay.
Yes.
So once the underlay is there, I'll be able to connect to these devices and do some configurations.
Yes.
Right? Meeting is being recorded. So this is basically, this requirement is basically this, whatever I'm configuring, this is basically what? The management traffic which I'm going to send across this connection, this connectivity, this internet connection, correct?
Yes, yes.
So when I send this information, this is called as what? Management traffic.
Yeah.
And the traffic is going to go through this basically this kind of service. So we call this as what? Management VPN. Like that. Okay, like that. I'm going to ask you now one thing, like that. To do this management VPN, basically, what type of connectivity will I require? This internet connectivity is there. Do I require a very high bandwidth internet connection at the moment?
No, not required.
Not required. Right? Maybe I'll just go. Maybe this 64K would be enough to do this configuration, because what I'm going to send maybe little 3-4 line configuration I'm going to send initially, right? Because I just want these devices to communicate in the beginning, like that.
Yeah, IP and subnet.
Very simple, basically very basic management like that. Okay. Let's say now I have done that. This organization, they said, okay, for this management, okay, we'll take up, maybe let's say we'll have just, I'm just for understanding, just like, let's say we'll go for today. Basically, we don't get kbps. Let us keep it very simple. Basically, today let's say, I'll say basically I'll go for only one meg, basically, 1 meg connections like that. Okay. Like that. So this is basically the traffic for this connection is basically internet connection is for what? For the management traffic to be sent across to all these devices. Okay. So for at least, are you guys there with me?
Yes.
Okay. Now see, we have done this basically. Now later on, basically behind all these WAN edges, ultimately what is there basically behind all these WAN edges? What you have?
The LAN.
The LANs, basically, your networks ultimately, which you want them to communicate like that. So this is basically, this is our data plane.
Yeah.
Right. So this data plane traffic, for this data plane traffic, will this 1 meg bandwidth will be good enough? No.
No.
No, because this is very this organization purchased only for basically in the initial, basically like that. So now if my data is huge, it's a big network. Anyhow, we are talking about SD-WAN means what? Scalable. We are talking about hundreds of locations. For hundreds of location, 1 meg bandwidth will not be. It's like nothing, basically. Kind of basically like that. So maybe you will require basically maybe 1 gig connections like that. So now what to do? What the organization will do? You already taken one service from some service provider, just minimum 1 MB connections for all these devices like that, and that internet is now on, and because of that internet we were able to manage all these devices like that. That thing is done now. But now when the data traffic is going to come, what we have to do? Now the customer would maybe they need to go for, maybe as I said, 1 gig connections now. Like this, on everywhere I go for one gig additional connection. Oh, sorry, I did not draw this. Do you think like that customer will do? Does it? Does this look normal?
No,
No.
Is it different branch routers or same location? VHS.
different branch.
No. See, they are in different locations. Basically, as I said, whether in the very beginning also, when I wanted to configure this, as I said, we need to have reachability, correct?
Yes.
Like that. So for that reachability, this organization, they took some connection, internet connection, as I said. And but the requirement from bandwidth point of view was not that much, right? So they initially went for only 1 MB connections, let's assume, like that. Okay. And so using this 1 MB connection for the management purpose, okay, we configured all this, we configured all these devices now. Now all these devices are basically are ultimately ready for sending what? The actual user traffic, the actual data traffic, right? Data traffic. But the data traffic is huge, basically. So for that data traffic, basically 1 MB won't be good enough, right? Like that. As per the business requirement, you require one gig connections, basically.
Yes,
So
each and every site needs one gig.
So now, like what I did, this, let's say this organization, they said, okay, we'll take one more connection from the internet service. Maybe that could be some other service provider also. Doesn't matter, like that. I'm showing this is internet cloud, not necessarily same ISP. This could be, maybe this is ISP1, let's say. This could be maybe ISP2, some other ISP possible, right? But just tell me, just for management purpose, will any organization do like this? Take up one internet connection. Do you require every day to use this management?
No.
Right. Correct. So normally, what will, in a real world environment, this is not feasible. You don't take two internet connections, one separately for management traffic and one separately for basically data plane traffic. No, we don't do that like that. Organization customers won't do that basically. Customer will say, maybe instead of this, basically, I would have said, okay, one option is what? In the very beginning only you take one gig connection. In the very beginning itself only you take one connection. That is one thing, correct? Or maybe in the beginning you didn't, while setting up, basically they said this, all this setting up and all will require, let's say, all this will require a month's time. So maybe initially you went for 1 MB connection, then later on you'll talk to your ISP, you'll say, hey ISP, basically upgrade, we want basically 1 gig connection, 1 gig bandwidth, you provide us 1 gig, we are ready to pay. So normally every WAN location will not have basically two connections, one separate for management, one separate for the data transport. Basically you will have only what? One connection which you can use for both. Management traffic can also go through, and basically data plane traffic can also go through. Again, let us relate this to our traditional WAN. In traditional WAN, basically we have two routers connected across some WAN service like that. Let's say our traditional WAN, router 1, router 2, like that. Router 1 has some networks basically. Router 2 has some networks basically, like that. I want this router 1 networks to communicate with router 2 networks basically. What we do? We'll possibly configure them as what? In OSPF, because tomorrow there will be more. So I configure OSPF routing, correct? So once we do OSPF between router 1 and router 2, then what happens? All these networks that get advertised, router 1 will advertise all its network to router 2, router 2 will advertise all its network to router 1, and finally they know all the networks, router 1 and router 2, then learn about all the networks, correct? Hello?
Yes,
right? And then ultimately what happened? The user starts sending traffic, guys. This user starts sending traffic. So how the traffic flows? Between this, the traffic will flow on the same link, correct? What about this OSPF traffic? OSPF also generates some traffic, right? Every routing protocol generates some traffic, correct? In case of OSPF, what will be the traffic? It could be hello messages, right? There could be sometimes LSRs, link state request will be there. If you have a link state request, against that you will be sending what? LSUs, link state updates will be there. So if there are changes happening in the network, if there are changes happening in the topology, OSPF will keep on generating its own traffic, right? Like that. Then that traffic also will go through what? For OSPF, do you have a separate connection?
No, same connection.
Right? It also goes on the same connection, correct? This is data traffic, and this is basically the control plane traffic. So data plane traffic and control plane traffic in a real world, in a traditional WAN environment, do we have separate circuits for this? No, right? Nobody has like that. We all use only one common circuit. So when we are talking about SD-WAN, do you think we'll have like this? Some organization will have like this environment separate. This is for the management. This is for management, or this is for control plane. You have a separate circuit, and this is for basically the data plane separate circuit. No, right?
No.
So in case of SD-WAN also, we are going to have what? Basically the same connection which will be used for sending the management traffic, the control plane traffic, all the traffic. Basically one single connection only will be used, the same thing. But provision is there. But in Cisco Viptela SD-WAN, they have kept a provision that if you want, if some customer want, they can have a separate management connection. Okay, and that's the reason they call this as what? Management VPN, like that. So transport VPN is the like the data plane VPN, and management VPN is something separate. Basically the management plane, control plane VPN traffic, basically. So what are the possibilities? Transport VPN can be separate, like here if you see transport VPN, this can be separate, and data plane can be separate. This is possibility. If customer wants, they can do this way. That is option is there. But if customer doesn't want, then can the transport VPN and management VPN can be same?
Excuse me, sir.
Yes.
In that case, we would require, two public IP addresses per,
Yes.
edge.
Yeah, you're right, Shekhar. If you have two connections to the internet, you'll get two IP addresses. Two interfaces will be getting wasted. Maybe.
Right.
Okay.
Okay.
So when you have like this, when some customer will do like that, they have kept the possibility. People won't do that because it is not feasible. It's not practically good also, but still you have this. When management VPN is separate and your data plane, that is the original transport VPN, is separate, then this is called as what? When management traffic is not going on the same circuit as the data plane, this is called as what? Out of band management. Okay. But if management or the control plane or the authentication plane and plus your data plane all go through the same circuit, then this is called as what? In-band management. So management can be in-band, management can be out of band. Most popular will be what? In-band. Because out of band, to do out of band, it is additional expenses, right? Just to ensure that my OSPF traffic is flowing, if I take another circuit, doesn't make sense. Correct, no? Like that. So nobody does basically like auto, because out of band basically you will require one interface separately will be wasted. You have to pay additional expenses just for sending some management traffic. But if customer want, they can do this like that. So basically now we have basically two transports. Two VPN basically. One is called as what? Transport VPN, and the other one is called as what? Management VPN. Transport VPN and management VPN can be same, or if the customer want, as I said, they can be separate also. If it is inbound, then transport and management VPN will be same. If customer doesn't want, then transport and management VPN can be separate. Clear, guys?
Yes.
Any questions? In-band management and out-of-band management?
Sir, the VBON traffic also will flow through management.
Yeah,
VPN
that's the reason I have written the management M, C, and A. A means authentication VBON basically. Everything.
Orchestration.
All the four plane traffic going to the same circuit, then it is in-band.
Yes.
Out of 4, data plane is going separate and the remaining 3 are going separate. Then that is basically out of band. Correct?
Yes.
Clear, guys? Now, if you guys can relate to in basically when we do GRE tunnel, what we assign, what we do basically. When I'm setting a GRE VPN, we create what? Tunnel interfaces, correct?
Yes.
And to create the tunnel interfaces, we have to create we have to assign a number.
Yes,
like interface tunnel number 0. Interface, we created tunnel interface. So the numbering starts from where? 0, right?
Yes.
Same way over here now. This transport VPN, and when I'm talking about management VPN basically. So when I'm talking about VPNs now, let me just write it down. When we have basically when we are talking about VPN basically. So when we have to create these VPNs, okay. So to create these VPNs, basically we have this range. So this is the VPN range for, in Cisco Viptel SD-WAN. You have to, when you're creating some VPN, you have to assign a number. and this number starts from 0. But now you have some basically reservations like that. From 0 to 65 you have like that basically. Okay, these are so many numbers basically, almost 65,000 let's say numbers are there basically. Okay, 0 number, there is 1 0 and the other one basically is the number called as 512. These two numbers basically are reserved for this transport VPN and management VPN. So if I'm creating, let's say, like transport VPN will be always there. See, this transport VPN will be always there. As I said, transport VPN has to be there like that. Okay, management VPNs out of band, it can be separate. Management VPN inbound, transport VPN itself can be management VPN. If it is inbound management, then it transport VPN and management VPN will be same like that. So as I said, now let's say some organization, they have decided out of band. Okay, some organization, they have decided out of band management. That means they say no, manage all the data plane traffic will be separate and the remaining 3 plane traffic will be separate. We don't want the data plane traffic to go along with the management control and basically the authentication plane traffic separate. This is called as out of band. In case of out of band, what is my possibility? I have transport VPN and I have management VPN, right? So 2 VPNs will be needed like that in case of out of band like that. If it is out of band, what is the numbers I can use? Let's say for transport VPN I use number 0. So if I use the number 0 for transport VPN, then for management VPN I have only left is what? 512. Okay, this is one possibility. The other possibility is, no, I said transport VPN I want to use the number 512. So if I use the number 512 for transport VPN, then for management VPN, what will be the number left with me?
0.
0. So these two numbers cannot be used for anything else. 0 and 512 can be used only for transport VPN and management VPN. Okay.
So we should be now, from now on, whenever we have SD-WAN scenario, we should be careful that if we are having other GRE tunnels with some other routers, then we should not use the IP tunnel 0 then. Interface tunnel 0, because it will again coincide with this.
Yes.
Is it true or they are not related?
Which is?
The GRE tunnel interface which you are talking.
No, I just made a
observation.
Made an observation, because then they will create problem, right?
No, I don't think they are.
No, actually, actually that what traditional GRE VPN, basically the VPN GRE interface tunnel number 0, it's not going to have any basically relation with this thing basically, because this is no longer now. These are no longer traditional routers now. They are basically what the WAN edges now over here in this scenario.
Okay.
If you have basically, let's say, as I said, behind this WAN edge, you have basically some router here basically. Okay. And maybe in another location over here also you have another router here like that. And now suppose between these two guys, you are setting a GRE tunnel, then that is a different thing basically.
No, on that particular device, we should not have that.
No, on that device, you will not get any option only, because you cannot use 0 for any other purpose.
Okay.
The moment you try to use the on this WAN edges, the 0 numbers, it will say no 0 number. If you want to use it, you can use it only for transport VPN or for management VPN. These are the only options. Transport VPN number can be 0 or 512. Management VPN number can be 0 or 512.
Okay. So just a doubt.
Yes, please.
So management VPN will have the data of all the vManage, VES, VBond, and how the VH is connecting, right?
Yeah, initially, as I said, we have to set up that fabric basically.
And
that.
transport VPN will have user data, or what data it will be
Yeah,
there?
data ultimately. See, first management, first you configure your network, first you set up the network, first we configure OSPF. Once OSPF is successful, then ultimately the user data will come. Na?
Okay.
So
So,
same way.
and we have rest of other data, other numbers, right? 1 to 6. Other.
I'll explain that what is this range? Why so big range is there? Right now,
Yeah.
let us focus this. I'll slowly come to that part little bit later, because right now we don't need that at the moment. Okay. First, let us clear this now. Now this is out of band. What about in band management? If it is in band management, let me hold on. In band management, transport and management will be same. It will be together now. You have only one VPN you want to use for both. In that case, what could be the number? I can use 0. Okay. I will use 0 only. Or transport VPN, I will say I can use 512 also. Or because now I don't want to have separate like that. So in case of in-band management, basically, okay, in case of in-band management, transport VPN always has to be there. I have to decide first transport VPN. This is important. Please understand, this is important. Whether it is out of band management or whether this is basically in-band management. This is very important. Transport VPN. So same way over here also, we have to define the transport VPN. So while defining the transport VPN, I have to decide what number I want to use. Will I'm going for 0 number, or I'm going for 512 like that. Okay, once I've decided, I'll go for 0. Okay, 0 is done like that. I don't want to go for out of band. Then what about this 512 band management VPN? Then what about this one? Even though basically, even though I'm not thinking of having a separate management VPN to send the data traffic, to send the management plane traffic, I want the same one single connection, the single transport to be used for all the traffic, basically, that is inbound management. Still we have to define this management VPN. See, management VPN and transport VPN, we have to define. That is there. We will use management VPN separately or not, that is different thing. But while defining, we have to define both. Okay.
Let me give an intro. So the thing is, if it is inbound, you can use both transport and management in either of the tunnel.
Yes, in either of this number. I can, if I've decided that inbound, I'll say, okay, transport VPN number is 0, or I will say, no, I don't want to use 0. Let me use 512. So I can use the number. Freedom is there. I can go for transport VPN number 0, or I can go for 512. As I said here, in out of band, basically, you see transport VPN, if you have decided transport VPN, you are going to use 0, then management VPN number will be 512. You have decided transport VPN will be 512, then management VPN number will be 0, like that. That is, we have to define clearly like that. In case of out of band, what is the requirement? If it is out of band, what is the requirement? Separate interface. Let's say here, basically I'm going to use, let's say, gigabit 0, like that. And then since it is out of band, there will be a separate interface which will be used for management, correct? 2 separate links will be required, right? Out of band, yes or no?
Yes.
Yes. In case of in-band management, what will be there?
Single link.
Single link will be there. Only maybe I decide which one, only one interface will be used. Maybe gigabit 0, or 1, whatever. I have to do only one interface will be used. So one interface will be part of what? One VPN. Are you guys aware of VRFs?
Yes, I don't know about this.
Yes, guys, are you aware of VRFs? Hello?
Yes, sir. Yes, sir. Yeah.
Have some basic understanding of VRF, right? I assume like that.
Yes.
Or let's
Segmentation of
huh,
customer
or
type.
yes, or let's say, let us not talk about VRF also. Let's say, let me keep it very simple. Let us take a very simple scenario switch like that. I have two devices on the switch. Okay. I assigned IP address from the same subnet to these two devices. By default, will they communicate?
Yes.
Right? By default, they will communicate because they belong to the same subnet like that. But if I want them that I don't want to change their IP address, but I don't want them to communicate with each other, what we do on the switch?
We'll put them in different VLANs.
Different VLANs, correct?
Yeah.
So basically, with the concept of VLAN, what we do, segmentation. I'll create basically this is VLAN 10. Maybe I'll say no, this is basically you are basically VLAN 20, basically like that something. I'll make it correct. The moment I'll do this, what will happen now? This particular interface, okay, this particular interface, it belongs to VLAN 10. This particular I make it belong to VLAN basically 20. The same interface. Next day, I come to the same switch and I say, okay, now you are becoming member of VLAN 30. I go and put that on that same interface. I say switch port access VLAN 30. What happens then? Then that port, does this port is now part of both VLANs, VLAN 10, 20 as well as VLAN 30?
Yes. No.
No. One interface of a switch, one port of a port cannot be part of multiple access VLANs. It can be part of only one access VLAN. If I say in the beginning switch port access, switch port mode access, switch port access VLAN 20, then on the same interface, if I say again switch port access VLAN 30, what will happen? It will immediately become member of VLAN 30. It will override, right? So one interface on a switch, can it be part of multiple VLANs?
Can be if it is a voice. Oh yeah, single
No,
voice and single text.
and
That is
no,
exception.
voice VLAN is not access VLAN. Voice is an extended VLAN.
Yeah.
Like that.
Yeah, it can be only one
Access VLAN means only one VLAN. One port cannot be member of multiple access VLANs. One, right? Like that. So same way over here now, we are talking about how many VPNs do we have in SD-WAN? Right now, how many VPNs are you guys aware of now? Whatever so far we have discussed,
and management.
2 VPNs are there, right? Like that. If it is out of band, if you see in out of band environment, you transport VPN, you have a separate interface, and for management, you have a separate interface altogether, correct? But what about in band? In band management now, basically, I want to use only one interface, right? I want to use only one interface in band management. If I'm using one in band management, can this interface be part of 2 VPNs now? No. So the concept doesn't change. One interface can be part of only one VPN at any given point of time. Same like switch port. It can be part of only one access VLAN at any given time. Same like VRF. One interface cannot be part of 2 VRFs at the same time. It can be part of only one VRF. So VRF, VLAN, and VPN, they are basically, we can say they are like synonymous. Clear, guys?
Yeah.
So when I want to use in-band management, okay, the VPNs, by default, the 2 VPNs will be existing. Transport VPN and management VPN are already there inbuilt. But the transport VPN in management VPN, they don't have the numbers. Numbers we have to decide. Okay, numbers we have to decide which will be the transport VPN, which will be the management VPN. These numbers we have to decide. and then we have to decide the interface also, which interface will be belonging to transport VPN, which interface will be belonging to the management VPN. Then once we have done this, basically, then we decide, are we going to use basically in-band management, or are we going to have out-of-band management, like that. It depends on what the two connections. If you have two connections, then you have out-of-band management. If you have only one single connection, then basically it will be what? Only in-band management. But you have the two VPNs are already existing in there. Okay, the two VPNs will be already existing there, like that. Let me show you now. So this interface we have to define. Interface has to be part of the VPN, like that. Interface has to be part of some VPN. We have to define which interface we want to use, like that. So let us start now this thing. Now a lot of talking I have done. Let me again show you the what do you think this if you see this diagram, what exactly do you think? Do we have in-band management, or will we have out-of-band management?
We can have both if we require, actually.
I see both interfaces.
As far as if you see the interfaces facing the outside world, you see basically two interfaces, right?
Except that
Yes.
Los Angeles.
But then the thing is that, yes, but then the thing is that basically from this diagram, somebody, right now, whatever discussion I have done, somebody will say maybe this internet is the transport VPN and this maybe the MPLS will be the basically the management VPN. Yes, it can be like that. Yes, it is. You are right. Basically, it is possible like that. But if you see the controllers now, see the controllers. What about the controllers? How many connections do you see controllers have?
One.
Like that. So these controllers have only one connections basically. On the controllers, we don't see separate connection, like when these controllers want to communicate with each other, they have only one connection. When these controllers want to communicate with this one, basically, like that.
Just 1 minute, sir. But the controllers will be sending only management traffic or the control plane traffic.
Yes, yeah. There is no data.
Send data traffic.
Yeah, they are not going to send. You are right, basically. Correct, so like that.
For them, only one
connection is only. Yeah, they will always have only one connection, like that.
We can have actually out of band management here.
Yes, maybe I can still have like this, if I want to like that. Let me just clean up this now. All this this devices, I can have one more interface here basically, and this interface can be connected like this separately, like that. I can want, and maybe I can exclusively have this as a management VPN, like that. So controllers also can have separate interfaces if I want, basically, like that. Okay, but since the controllers basically normally they are not going to generate any data plane traffic, so we don't or no organization will do like this basically. On the management on this controllers, you will have separate connections basically. So from the controller's point of view, basically it will be they will have only one single connection. But this WAN edges, basically there is a possibility like that. But if you see Los Angeles, basically take this branch Los Angeles. In Los Angeles, you see this I have written here, LAVH1, and this is LAVH2 basically. If you see LAVH1, it has only one connection basically. So if this vSmart is sending some traffic to this LAVH1, how it will come? It will come only like this, correct? So this is now control plane traffic, like that. And suppose this computer is sending some traffic. This computer is sending some traffic to maybe to some server over here. Then this is also going on the same link. So this is basically the data plane traffic. So control plane, maybe management is going to send something, authentication plane. So all this traffic ultimately, and the data plane traffic, as far as this LA VH is concerned, basically it is what single connection, right? So for this is basically will be what in-band, right? And this also will be in-band because this one also has only one connection. But when we see here Dubai, New York, and this data center, this three locations, when we see basically, we find that they have two connections basically.
Sir,
Ah.
this LA VH2 has got connection only with the MPLS. It is, did you miss it or it is by design?
No, by design, because I wanted to have all the possibilities, like, you know, redundancy also, and basically single point of failure also.
Okay.
You know, like some locations, you know, that much traffic is not there, that much volume is not there. So organization will say, okay, we'll have only single connection. If that single connection fails, okay, no problem, that branch will be isolated for some time. When the internet connection comes up again, and that anyhow it's not that critical. You know, all the location in, if you take an example, a big enterprise basically.
LE is also connected via MPLS, right? I can see an arrow. Is it not?
Pardon, can you come back?
LE is also connected via internet as well as MPLS, right?
Who is connected?
Los Angeles have connectivity via internet as well as MPLS, right?
Yeah, one
but
WAN
one
is on internet.
one is connected to internet and the other WAN is connected to MPLS.
Yes.
Okay.
Only from data center you have two connectivity, are both on internet as well as MPLS.
Dubai also same thing, internet and MPLS. New York also internet and MPLS, like that. Only Los Angeles I kept it one connection. Los Angeles also there are basically, maybe there are two different departments in Los Angeles. So each department has only one connection.
So here LA will not have a redundant.
Yes, suppose.
Yeah.
You're right, guys.
But LA is connected. VH1 is connected to VH2. I think we can move through that also.
No.
No, why not? Redundancy
Listen,
will not be there.
listen. Let's take example of only LA. Okay. Forget about right now LA2. Think only from LA point of view right now. Okay. LA has how many connections going outside? Only one. If that someday if this connection fails, then what will happen? LA will get isolated. Take example of Dubai. If Dubai has two connections, if this connection goes down, Dubai can still reach the world through this MPLS connection. Dubai can reach still all the other locations via the second connection. So Dubai has redundancy, New York has redundancy. The data center, when I say data center, that means it is very critical. Reachability must be there at all time. That's the reason. You see, there are basically two advantages I have kept there. And these two advantages basically they have two transport, basically two internet, two connections, basically WAN connections. So in case of data center, Dubai and New York, they have redundancy. If one connection goes down, they are still reachable. Whereas in case of LA now, if you see, you know, LA1 has only one connection. So if that connection goes down, this LA gets isolated. Tomorrow, okay, same thing with this guy. If LA2 connection goes down, then LA2 gets isolated. If both the connections, if LA1 connection and LA2 connection fails together, internet also fails, and basically MPLS also fails for LA, then LA will get isolated. No other way, no other option. But see what I have done now, like that. I have done a connection between them. LA1 and LA2, I have made one connection between them. If you see on the diagram, gigabit 0/1 connecting to gigabit 0/1. Clear? Here, do you see now? So
yeah, in this case, redundancy will be there, right?
Yes, but that is not by default. Did you guys get the course blueprint yesterday? I shared, no? Hold
You
on.
have shared labs, 6 labs. That's one, and
Hold on. Let me just.
Labs
Most
and ID list we have got.
One second. Let me see this.
you have initially shared, sir, with
Ah, yeah,
yeah,
yes.
you
yes,
may
yes,
share
there
it
was
with
an
everybody.
Uh-huh. So this is the blueprint basically. So we are talking about this labs, if you go down, I'll share this PDF also for your reference. I thought it might you might have already received basically. See here, the last lab.
Okay, that is for the last lab.
Yeah. So LA, that thing will be doing in the end. Like, what if some location has only single connections basically? But basically, there are basically two vantages in the same physical location. You have two vantages for two different departments basically, like that. Then can they back up each other? Yes, that is possible. That is called as what, T-lock extension, which we'll do later. Okay. So based on that, basically, we'll be
but
doing this. Yes,
this
please.
is normally possible, right? It is not in SD-WAN, but it is normally possible between two edge routers. You can have tunnel when the traffic goes. You
Normally,
can.
yeah, traditionally you can have that like that. But in case of SD-WAN, it will not happen like that by default. In SD-WAN, this feature is called as what? T-lock extension. It is called as T-lock extension feature, like that.
Oh,
So we'll see that, like we'll see practically when this internet connection for LA VH1 will go down, then the traffic, whatever is coming to VH1, it will forward the traffic to VH2, and then it will go through the MPLS cloud and go to the other locations. Same way, someday the LA VH2 MPLS connection goes down, then in that time LA VH2 will forward the traffic to VH1, and then VH1 will forward that traffic via the internet cloud to the other locations. So they will back up each other both, like that. Okay. So we'll see that. So that's the reason I've designed this lab to implement all the possibilities. Some branches will have redundancy. Some branches, some location might not have redundancy, like that. So in that case, what to do? Okay, guys.
Yes, sir.
yes.
So actually, this internet and MPLS, these are basically not for management and the data plane. We are not talking about data plane and management separately. It will be inbound management only. So in the lab environment, we are going to have inbound management. So this MPLS is not for basically like internet is for data plane and MPLS is for management. It's not like that. Or MPLS is for data plane and internet is for management. It's not like that. Internet and MPLS both will be used for data plane, like that. And internet and management both will be used also for sending the management control and the authentication. All the four planes traffic will go on both the links. That means basically it is basically redundancy environment. This is a redundancy basically when redundancy is there. Okay. So we don't have separate like transport. This is transport VPN and this is basically management VPN, or this is management VPN. This is no, it's not like that. This will be we are basically doing inbound only. So it will be inbound management. Okay. This is MPLS is backup. This internet will be our primary, and this will be our backup. So just think that initially everybody has only internet connection. We'll build up this thing later. Backup will bring little later. So let us now start. First thing is what basically, as I said, we require what? Reachability. Okay. We need reachability between all the devices. So first thing is what? You have to take a connection from the service provider ISP. So ISP has to do some configuration, correct? So that is this is the first device which we are going to configure, iNet router. Internet router, we are going to do the configuration. That is the first thing we are going to do. So let us now start this. Now I'm inside the IOPEX folder already. Okay. Okay, this later on during the lunch break, I would request, I think, two guys, you have to basically connect and test your connectivity. One is Velu, I think, and I don't know who else is there. Rest all guys have basically identified their folders. So you, Lakshman and Velu, you guys please, test your reachability through your IOPEX laptop to my server basically. And once you are able to connect, then you rename like this, user 7 hyphen Lakshman, user 9 hyphen Velu, like that you rename these folders. So that means you will be able to understand that this is your folder, this is your lab, like that.
Hi, Kam.
Hello.
Prashant, sorry to interrupt. Once I get into my folder, I don't see the lab thing created. I've just tried yesterday, but I'm not sure whether it has been created or not. I'll do it, check once again. If not, I'll reach you. Okay.
Prashant, you're talking about Prashant, no?
Yes, Prashant.
Just hold on. Let me see this now. Oh. Where is that thing?
It is user 6, sir.
User 6, Prashant.
Anyone user, just folder
yeah.
we have to check.
It's there. Yes. Okay.
Okay, it's fine.
Yeah. Yesterday itself, basically, later on, I uploaded all in all the folders. Basically, if you see,
Sure.
I can.
Okay, no problem. Thank you.
Okay, till end. Let's go to, let's say, user 10 Jagdish folder. There it is, like that.
Okay, thank you.
Okay. So that is done basically. Okay, don't need to worry. Okay, now see, outside this folder, I have kept one more file. This is for me basically. This is which I'll use for myself. Okay. So you guys, you have your own folder names. You should go into your own folders and you should practice your own lab. Okay. This lab, this file is for me basically. So now I'll go into this file. Scroll down. I'll say open. Sometimes it doesn't open in one time. So try it basically a couple of times basically. Okay, let me. So see right now, first thing is what I will set up the ISP. Like we are talking the ISP, we have to assign the IP ISP. So I'll start this ISP router first, internet router. Now all these links will have some IP addresses. Okay, all this, if you see this router, let me just move this IP address over here. In this same thing basically, for the time being, I'll keep it like this on the side. So the MPLS connections will be all from this 10 network, and whereas all the internet connections will be all from the 180.10 network, like that. So this iNet router, if you see iNet router, Ethernet 0/0 is connected to data center DC1. Basically, then iNet router, or I can keep it right now a little bigger. E0/1 is connected like that. So all this in, so we need to assign IP addresses like that. Then it will, this side it will have an interface belonging to 192.168.0.0/24, the IP address. Now what I have done, for ease of understanding, all the IP addresses of this inet router will end in .50. I have kept like that. I have decided like that. All the interfaces of this inet router, their IP addresses will end in .250. Same way, if you see MPLS router, all the interfaces of this MPLS router, they will end in .251, like that. So 250.250 will be like anytime you see a packet, in that packet, the IP address, the last number is 250. You have to understand, basically this is basically the inet router IP. So I've created like this system. Now what to do? We have to configure this like that. So what exactly we need to configure? For that, I think I shared a PDF. Let me go to that, open the PDF. So if you see, so first router is inet router. So we have to configure this inet router with this IP address. See, I have written all the connection, that E0/0 is connecting to data center DC1 VH1. E0/1 is connecting to data center 2 DC2 VH2, basically. VH1, basically DC2 VH1, VH1, same way like that. So now we have to configure. Then we have to put a route basically for internet, basically. I need to assign IP address like that route. This IP address basically as per your Wi-Fi, basically. So according to my Wi-Fi, it will be 190. The gateway will be not 200. It will be basically 192.160.1. We'll see that. So now we have to configure this. Now how do I configure this router like that? One thing, like I can straight away go to this router. Let's see. Let me also relate the same thing. So it's a blank router right from scratch. Now basically we don't want to, like if you want, you can do manually, or you can assign all the IP address, or if you know that this is basically we are already used to assigning, it's not a big deal basically. So for your quick reference, basically what I have done, basically, I'll be copying a folder. Okay, like this, I've created a folder, SD-WAN lab router configuration folder is there. Okay, so I already created a configuration file for this inet router. So this I'll be sharing for each one of you on your once you any text on the desktop itself, you'll see like this folder. I'll copy paste this folder for you guys. So I go inside this inet router, and you see I already created this configuration, all the interfaces, no-shot, everything basically. And see, the default internet route is actually my gateway is not 0.200, it is basically 0.1 basically. So I'll simply select Control A, Control C. I come to this my router, inet router, right click, and my inet router is ready. Internet ISP is ready with their configuration. ISP router is ready with their configuration. I can test now that this inet router, can it go to the actual internet 8.8.8.8. It's not able to go. I'll test reachability basically first to my gateway. 192.168.0.1. It's not going to go.
Sir,
It's not going to work.
no shutdown is given on the interfaces.
No, see, I already done. They're all up.
Okay.
The problem is, can somebody tell me what is exactly the problem? I'll see the diagram. What is the problem? Why it is not able to go to the internet? The reason is, if you see this iNet router, how it is going to do this Wi-Fi internet? It is going through this switch. This switch I did not power on, right? I just connect on to switch on this router only. So this switch also needs to be started, because it's not directly connected to my Wi-Fi, na? So let the switch start. Let us take this. Let's see the switch has started. Yeah, switch has started. Now if I come back to iNet router, up arrow, let's test my reachability to my internet gateway first.
Sir, that switch configuration has been done?
It's a normal, just there
Okay.
all the interfaces will be in, let's say, VLAN 1 only.
Okay.
Okay, let us check the V switch still. So all the interfaces, if you see slot 0, all the 4 interface, slot 1, slot 2, slot 3, all the 4 slot, all the 4 interfaces, they're all in VLAN 1 only. Basically, there's only by default only VLAN 1. It's a very basic thing, okay? Like that. For testing purpose, I'll create a interface VLAN 1. I'll assign some IP address on the same subnet 192.168.0.254. Now let us test do ping 192.168.0.250 iNet router IP. So not there. Okay. iNet router show IP interface brief. Oh, you see, only 4 interface got the IP addresses. On the iNet router, only 4 interfaces got the IP addresses assigned. The other interfaces, they did not get IP. As per the diagram, which interface of iNet router is connecting to the switch?
1/2, I think.
1/3.
1/3.
3, huh?
1/3.
3. Okay.
Okay, like that. So if I go to this guy, iNet router, 1/3 is unassigned basically. It does not even have IP address. Now the question is, why it did not happen? Because if I copy pasted, why it did not happen? Oh, see the problem.
No, I think original configuration was not there. See, because it is in 0 up till 0/4.
No, actually, it should have been, this must be 1/3 here.
Okay.
Let us correct this one. 0/0/1, 0/3. Let us compare this one. 0/0 180.10.22.50, that is correct. 0/1 is 180.10.122.250, that is also correct. 0/2 is 180.10.11.250, that is also correct. 0/3 basically is 180.10.33. So up to 4, this is good. Then this is where it changed basically. Now 180.10.44.250, where is this IP? So let me go to this PDF. Where's our PDF? iNet router. So 0/0 to 0/3, they're correct. Now then it basically it starts with 1E1/0, E1/2, and E1/3. E1/3, just now I did the IP address. E1/0, the IP address has to be 180.10. Okay, that means this IP address basically has to be 1/0. Then I require one more interface. 1/2 control C. It has to be 1/2. 1/2 again as for the PDF. 1/2 IP address has to be 180.10.111.250. 111. 180.10.111. So I just need to 111. Okay, I think this is there now. Control A. C. I come back to iNet router. Again paste it. So IP interface brief. So this is up, this is up, this is up. All the interfaces look up. Let me now ping 192.168.0.254, the SVI on switch VLAN 1. Yes. So then I should be able to ping my Wi-Fi modem. Yes. And now I should be able to go to the internet. This iNet router can have internet accessibility. Yes. Thus, the interface names, basically were wrong. Basically, that's the reason the configuration did not got fully copy pasted. Anyway, now I corrected that file, so it should not be any issue for you guys. Okay. So if you just simply copy paste that file, or you want to copy, manually assign the IP addresses and all, it is up to you how you want to do like that. All the interfaces. For your reference, this iNet file, this folder will be there on the desktop. Okay. So now internet is ready. Internet is ready, basically. Now you tell me from which device you want to start. Which is the first device we want, basically, we want to bring it, reachability, we need to have reachability.
Hello, sir, I don't have desktop file on the desktop, configuration file. It's only here.
No, it's right now not there. I will copy paste this. No, I will show it and then I'll paste. I said,
okay.
When later on, when you will connect, that time you will get it, right? Okay. Right now you don't need that. When you will get that time, you can use it. Okay. Because I want to pace myself so that any issues, if I encounter, it will correct it, and then the correct only thing, the correct configuration only should be there available to you guys.
Sure. Thank you.
Yeah. Right.
Sir, we'll take a small break.
Yeah, I think so. We should. It is 12 now. Okay. Now, before we do further configure, let us take a small break and come back. Okay.
Yes, sir.
Yeah,
you stopped this one,
recording
sir.
now. Recording.
It will become very long.
Yeah.
And if it is